Hello everyone, my name is Mateusz Pusz and I'm the C++ evangelist. Well, at least that's how my colleagues call me. I worked at Intel for many years and now I'm working at EPAM Systems, and I also having my own company called TrainIT, where I'm doing C++ trainings and consulting for engineers in Europe. Can be found on conferences like this and others regarding C++. I'm also here in the program board of this conference, and I'm responsible for their path, so it's the path of C++. So thank you very much for attending this one, coming to us, and I hope we will have really nice C++ path here for the first time on that conference. I'm also a member of ISO C++ committee. I'm working right now on C++ 20. And I thought you might be interested what highlights and what features we can expect in the new version that will arise in 3 years. So without wasting too much time, because we have a lot of slides and features, I will go to the content. Please note that it turned out that I have so many slides and we had one empty slot in the agenda. If you probably saw the printed agenda, we have one empty slot after the lunch. During this lunch, I will provide the second part of this presentation, so you are welcome to join it. So as much as we will talk right now here, it will be in the first part, and we'll continue after the lunch. Talking about the C++. C++ was a bit stable, and there was not much things happening here for many years. Many probably of your colleagues said that C++ is dead and you shouldn't put effort in it and so on. But it turned out that after, let's say, 2005, 2006, when CPUs stopped to increase, CPU clocks frequency stopped to increase, C++ gained a lot of attention, especially from Microsoft and many other big vendors on the market. And you can see that from 2005, 2006, a lot of things started to happen on this graph. We have this blue line that's called International Standard Document. This is the official paper that describes all of the features we have in the standard. And all of those green ones are the so-called technical specifications. Those are also the standards of ISO, but this is not that strict and that big document as official ISO C++ language document. Those are smaller features, and these are basically, the papers are feature specific, like networking, file system, concepts, ranges, modules, and so on. And they are parallel to the standard, and they have their own lifetime and versioning. When those technical specifications are ready, and we have some feedback from the community, they think about they liked and think about they don't like, we sometimes fix it a bit, modify something, and merge it to the standard itself. In C++ 17, we had merged file system, we've merged library fundamentals version 1, most of it at least, like variant, optional, and other stuff. We also merged parallelism version 1. For C++ 20, we already merged concepts, so we will have concepts in C++ 20. At least I hope so, because they were already in the standard in C++ OX, so-called. They were merged in, and they were then merged out from the standard right before C++ 11. So I hope this time we will make it. And probably we'll have a few more merged to the standard, but it's a bit too early to say exactly which of those. I hope for ranges, at least a bit of it. Coroutines, well, maybe modules, I hope so. We'll see how it works. Talking about how ISO C++ committee works, basically, ISO committee is a huge international organization where many things are happening. So there are subgroups. This is the joint technical committee of ISO and IETS. And this is subcommittee 22 responsible for programming languages. It turned out that this year we are creating a subcommittee in Poland for programming languages. We'll have a Polish committee officially, and we'll join ISO as a voting member, not an observer. So if you want to join us in ISO, you are welcome to join too with your company. Because you may right now represent Poland in ISO C++ committee. Michał Dominiak from Nokia is doing that for Poland. And this is basically the paper we have. This WG21, Workgroup 21, is responsible for the C++. We are doing this C++ paper. And you can see here 2 columns. We split our work to the core language and to the library side. And there are also 2 layers here. Evolution groups are responsible for finding the direction, how the language should change. So we are accepting if that feature is nice or not, if we would like to have it in the next standard or not. The groups, core work group and library work group, are mainly responsible for so-called wording. So how to spell it in the standardese, specific English-like language, how the papers are created. And they merge basically what we decide here. They modify some words in our proposals and merge it to the official standard. The input we get in evolution groups come from either us, so the authors and members of the committee, or from the study groups. There are right now 16 study groups. In Jacksonville, we created 2 new ones, tooling SG15 and SG16 for Unicode. So we have a lot of study groups working on the content that is the source of those technical specifications, for example. And also all the papers come from guys like you, from the guys that have really good idea and would like to see something in the language. So if you have any ideas, please feel free to submit a paper, and then I can help you. You can ask me if you don't know how to write a paper, but you have a good idea. Everything starts with a good idea how to modify or add something to the language to make the benefit for all of us. Status of major features right now, as of, let's say, March 2018, after the Jacksonville meeting. Coroutines will probably made it to C++20, we'll probably merge them. Contracts, I think they are really also nearly ready. We have some problems with ODR violation rules, but I hope that we'll solve it. Ranges, some of them, the core concepts of them, like those concepts like equality, comparable, we'll talk about them a bit, will be probably merged to the 20, and rest, we don't know, either 20 or 23. It depends how much work will you have. Modules, core concepts of the modules probably will also made it to C++20. We have modules in 20, but rest, we don't know yet. We have some issues how to handle things like headers, how to do pointing cloud in a module, how to handle macros in a module. Those are the things we still don't know how to solve in the best way. Reflections. So we'll be able to reflect in compile time or in runtime on some structures. Probably we have a technical specifications in C++20 timeframe, and probably it will be merged to C++23. The same for executors. And in fact, executors are the things why networking TS and future.den and async2 cannot come to the standards, because they depend on executors. Without executors, we cannot do them as we would like to have it. So those features are ready, but they are waiting for executors, and executors seems to be a bit sleeping. We hoped it will be ready for 20, but it will be probably 23. Do you have maybe any questions regarding this? I hope that you find it nice, or you are like disappointed with the progress of 20. Yeah, so the comment is that the networking part is missing. Yeah, it's a problem. As I said, we thought that executors will be ready, but we have a few of the proposals, and the study group 1 is providing us with updated feature based on our feedback, but it turns out that it takes a bit longer than we expected. We are not really sure that the design is ready. They introduced a lot of small types in order to make executors work. They are like many different types to make it work, and we are not sure if that is the easiest way to do it. So we are waiting for some implementation experience to find out if it's really the best way. Okay, so from now on, I will provide a preview of the features we'll have in the next language, in the next standard, features that were already decided to be merged or are already merged to the C++20 draft. This presentation will be a bit hard to follow because it's like a machine gun presentation. I will just provide features after the features. It's really hard to connect each of them with each other. So I hope that we'll be able to follow me with that. If you have any questions, please ask, and we'll answer them. But please know that we have many features to cover on those 2 sessions we have today. I will refer on every slide with the feature. I will refer to so-called paper number. The paper number is paper with the proposal and a detailed description of the feature. So if you would have any more questions regarding specific feature, you can just Google for it and find it. This is a tool that you can use for finding the papers. This is WG21 link. You may do things like slash and then provide the paper number, either with just the specific number or with specific revision, and it will find it for you. You can always find also the latest version of the standard, for example, with this link, for free. If you didn't know about this, it's the best way to find the latest version of the C++ standard draft, and you don't have to pay for it. Because the official ISOP paper, the specific version of these revisions are pretty expensive. Okay, so let's talk about the new features introduced to C++20. First of all, we have concepts. As I said, it was a long way to add concepts to the language. We standardized technical specifications 2 years ago, but for some time we didn't have a consensus to merge it as is to international standards because there was some controversy regarding the so-called terse syntax and introducer syntax. I will show you the examples in the next slide. What does it mean? And because of it, it was stalling all the time. So we decided to merge it without those features and work on them later on. You can find this paper with all the details, 734, about the concepts. This is the exact paper that was merged into the international standard until now. So this is how concepts look. Concepts are things a bit like templates, but you have a concepts keyword here, saying that is a concept sort table. Here in the braces, you defined what sort table means. I will not scope on this right now. And you can then say in any function or a class, you can say that the interface requires sort table. So you have template type name T, and this T has to be sort table. This is how you specify the requirement for this sort function. You can also have the so-called shorthand notations, saying instead of type name T, you can just pass sort table here. And this is accepted and merged to the standard. The things that didn't make it is so-called terse naturalist notation, where you were able to just provide the concept name as a function argument. And the main problems here were if that's a template or not. People would like to know if they're working with a template function, a function template, or with typical regular function, because you have to handle it a bit differently in the body, for example, like type name or template disambiguators. You have to provide sometimes or not. You'll find out later on that we removed some of those restrictions, but still, people would like to know that's a template, and that's why there are so many controversies here. Also, people didn't like too much the concept introducer notation, saying that you are introducing some type sec that is used here. This is also not merged. So, this is, for example, some function that just compares T with some other, maybe some global variable or some member in a class, but we expect it's the same type. And we are just doing the comparison, equality comparison here. And let's see here. If you call the foo with string ABC, it's okay. Yes, you can compare string with string. But if you will be, let's say, silly enough to try to do it with mutex, you have an error during compilation. Yes. And you probably know how those error looks, yes? This is a long pile of lines of errors. Here are 290 lines more, if you don't see it from the back of the room. This is how it looks, yes? And you have information about all the instantiations that the compiler tried to do and all the errors you got. With concepts, you'll be able to say that something is equality comparable, that it requires A and B of type T, and A and B should be a valid operation, A equals B should be a valid operation, and it requires that the return type of this operation should be of Boolean concept. So it means that it should be basically convertible to bool. And with that, you just provide this, for example, function, or you can pass equality comparable here. And with that, you just get a really nice error message here that looks like this. In function void foo, we cannot call the function because there is not equality comparable stuff here, because constraints are not satisfied, and you have all the details here in really nice error message. This is basically what we are striving to. We are trying to make the concepts and the contracts, let's say compile time contracts, more easy to follow, easier to understand, easy to provide diagnostics on them. So it should be a big improvement for all the users. Well, that's all I have for concepts. And the other really big feature that was merged right now in Jacksonville is the date library. Did you maybe see Howard Hinan's presentation on CPPCon, I think 2016 on date? And that's a library that Howard written. It's really, really good. You can find it at GitHub. I use it for production like in 3 years now. And now it's being merged to the standard. We have basically the support for dates. This is C-like. How do you would like to find what day of the week is July 4, 2001? Yes, you have to have this structure TM and fill it with all the information. There are some tricks you have to do. You have to subtract the year 1900, and the month is indexed from 0, not from 1. So it's also so counterintuitive if you are just converting the numbers. And you have to provide a lot of other stuff, like here, if you are using daily saving time or not, or you just would like to have them automatically determined, and then you have a result. With C++ and date library, we'll have to type something like this only. So basically, you just use CHRONO namespace that you probably already know, and we just say that we want to have a weekday, so the name of the week, basically of the weekday, for this date, and you just pass the date in such a format, saying July 4, 2001. It overloads operators to make this work, but this is I think this is in a good fate. So it works and it's really intuitive. So goals of this library: seamless integration with existing stuff, type safety. This is compile time safe. This is one of the best libraries I've seen after CHRONO. I love both of them. Nearly, I think, no compile like runtime overhead with really full compile time verification. I think that Howard did a really good job there. Detection of all the errors at compile time, it's really, really fast. And basically you can nearly do all the conversions in compile time in static assert. So this is really, really nice. It is really easy to use. It ends up with readable code, as you can see, yes? And yeah, there are no artificial restrictions on precision. You can use any precision you want, or at least there are no problems with that. Examples. For example, we have type year, month, day, and it provides here, this is the year 2016, month 5, so it's May, day 29. You can also specify the same date in that way, 2016 year, May 29 date. Basically, you have to say which one is year and which one is date with day with those user-defined operators, because otherwise it will not know exact direction probably. You can also say that you want to find 5th Sunday of May of 2016, and it will also work. Of course, if there is a 5th Sunday in that month. And if this is not, you have your own way to handle the errors of that. This is specified and exactly described in the documentation of dates, so you can find it, how to do it. It's up to you how to handle the cases where there is no 5th Sunday in this month. So having the same date, you can have a time point from it with sysdays. So this is basically the UTC time. And this is the same time point you know from CHRONO already. You can static assert on it if it's exactly what you expected. And basically you can make it back from the time point with that to the date easily in compile time. Also with date, there comes a time zones database support. So basically we are able to handle all the time zones. It has to be handled in runtime, unfortunately, because all the time zones calculations have to be done based on so-called IANA database. That's a huge database with all of the information there, how these time zones were ever provided in the earth. Like you can find things like what was happening like 400 years ago, and so on. So basically you just provide a specific time point, like this date and specific hour you have right now, and you say you want to have it in, what time is it in Tokyo right now, and you just have it in Tokyo time. Easy to use. Yeah, this is a minimal extension to CHRONO. The civil calendar is supported. We have formatting facilities already done, and we have several clocks added to the CHRONO to support this IANA time zone database. You can find documentation about the calendar and time zone on Howard Hinan's GitHub. This, as I said, this is date library. Is really of high quality. I'm using this in production for 2 or 3 years. You are welcome to start using it right now. You don't have to wait for C++20. There are also really nice video introductions from CPPCon about those features. And you can find the full implementation on GitHub, as I said. Yes?
One crazy question because of these time zones. Is the database built into the binary during compile time, or is it like a separate file that is shipped alongside with the binary?
Yeah, so the question is the database compiled time into the binary? No, it's not, because it may turn out that you will have a server running for many years and the IANA database will change because some governments decided to change their time zones daylight saving times. Like, for example, Poland tries to do, probably from the next year or something. I've heard about this at least. So you can just patch it in the runtime. There's support for it. Span, another feature that we were waiting for a long time. If you use the GSL, Guidelines Support Library, you probably know the type already. That's an abstraction that provides you a view over the contiguous array of elements. It's not a container. It's similar to string view, yes? It's just like a reference type providing you the pointer to the external resource. Because of it, it never performs any free store allocations, yes? You never allocate, you never delete memory with that. It's just a pointer and a size. But it's really handy. Basically, the definition looks like this, that you have a span that has element type you store in it, and you have so-called extend with default to dynamic extend -1 saying that it's sometimes that's runtime specified. If it's not runtime specified, you just provide a number here and it's compile time specified, then you have fixed size. I'm not sure if that will be the final version in the C++20 because there are some proposals to change it, but we'll see if that will be the final version of span in the standard. So basically, if you want to use dynamic size, you just allocate stuff and pass it to the span, saying here is my pointer, here is my length of my data. For static size, you have like array of 10, and you have span int of 10, and you say this is my fixed size span of 10 integers. If you would like to do it with 20, you have a compile time error because the compiler will verify that the size of the array and size of span is different. You can also pass this array to the runtime or dynamic size span, yes, and just forget in compile time what was the size of the array. You have the information in runtime then. This class, of course, in compile time has only a pointer as a size of, and in runtime has a pointer and a size. So the size of this type depends on the type of operations, if you are using a dynamic size or static size version of implementation. So basically you can, with that you can pass or assign or construct fixed size spans from another fixed size spans of the same length. You can always create dynamic size from any fixed size span. And also fixed size span can be always created from dynamic size span, but you have to make sure that you are doing right. If you are doing wrong, you have undefined behavior. So it's up to you that you made sure that the size is okay, yes? We are not passing any additional branches, if checks, and so on, any exceptions being thrown if the size doesn't match, yes? It has to be as fast as possible. You have to make sure that the size is okay before you will do the assignment, for example. I will just go quickly through the interface. You can see that there are a lot of construction things. You can construct it from the pair of pointer and count. You can have it from iterators. You can have it from static typed array. And what else? You can do it from any container, STL container. It will just take the size from it. And that's basically most of the most interesting stuff here. We have element access iteration, so you have index operator and also typical operator with the same argument, and you have data to get the pointer to the first element, or to the beginning of the buffer, let's say. And also we have iterators, of course, but begin, C, and so on. There are also some helper functions, like sbytes, as writable bytes, that provides you information and allows you to pass things as span of const byte or byte here. So basically you, let's say, cast your buffer of, for example, of integers to buffer of characters that you can just pass through the network or something like this. Yes? And you have, of course, all the comparisons for this type. For now, it's for span. I don't think it will be added to any other, at least for now. There was no proposals, but you can write them. And also, we can create a subspan from span. If you work with basing string, you probably know such of this interface. You can just take first elements or last elements or some subspan from the middle of it. So basically, it's really easy to work with those. Basically, span is like a range. It can only shrink, and that's really helpful because it solves a lot of problems that it cannot be expanded easily. It's really safe because of it. And of course we have first, last, and subspan here functions. So as a summary of span. It's cheap to construct, copy, move, and use. Users encouraged to use it as a pass-by-value parameter because it's really small. It also doesn't have a trivial destructor, which makes it possible to be passed in registers. So it should be really efficient. And that's basically all about the span. We will now go to the next major feature that will be added in the next standard. There are several papers here that added it. This is also called considered comparison, or otherwise spaceship operator. You probably know it from other programming languages. It will be added right now to the standard. So let's assume we have in C++17 you have a class P that has members X and Y. Right now, to provide all the comparisons, you have to, even for such an easy class that nearly doesn't have any interface because it's like simple data, you have to provide all of those things by yourself. And you can make a lot of problems. I've seen problems where things like less or greater were exactly not the opposite one of it because someone made some mistake or copy-paste error and put exactly the same implementation to both or so on. It's error prone. With C++20, you'll be able to write a new operator called starship operator. Basically, it returns you some type. It can be auto, and it can be automatically generated, member-wise. And it returns you value less than 0 if A is like less than B, greater than 0 if A is greater than B, or is equal 0 if A and B are of equivalent types or values. So basically, it reminds me of something like memcompare or string compare and other functions from CS. Yeah. As I said, it has member-wise semantics by default. So basically, if you are fine that you will first be comparing X and then comparing Y, you just do equals default and it will generate it for you. If you're not fine with that, you can type it by yourself. So basically, here's a bit more complicated stuff. This is, let's say, case-insensitive string that stores a string inside, and you want to have operators, comparison operators with the same type, so comparing case-sensitive string with another case-sensitive string, but you also, let's say you want to compare it with const char star, and you have to type it twice, yes, with the second argument and the first argument. So a lot of boilerplate code to type. If you would like to add support then for string views and strings, you can just imagine how many lines you have to type. With the new feature, you have to type only this. You type only information that you are comparing a case-sensitive string with itself, or you're comparing with const char star. And you say, how do you compare that with some, yeah, here you just pass things to comparison function. And that's all. This one covers both of the cases, this and this. It generates those functions and those functions for left and right, automatically, this one. You can also see that here we returned not auto but weak ordering. And basically, there are a few things that you can return here instead of auto. Because if you are using auto, it will be automatically determined which things that can be returned from here. The most wide stuff will be returned, but if not, you can provide you by yourself what is the ordering here. So basically, it says if A less B is supported, then you have a thing called ordering. If A less B is not supported, then you have only equality, yes? Equal, not equal, and no other functions will be generated. If it happens that for every A equals B, f of A will be always equal f of B, then you have strong ordering and strong equality. If for every A and B equals, the functions using them will not may provide results that are not equal, then you have weak ordering and weak equality. As a funny thing, there was a proposal to put this implementation, all those types, to a header that's typed equals. So basically, if you will be pound including this, you will be pound including Starship operator. But sadly, it didn't make it to the standard. No, it was just we weren't silly enough to do it. But it was the second the most voted proposal for the header name. It nearly did it. But it was fun, though. Okay, so here is how you can do it by yourself if you are not like the order, by default order. I did it here exactly in the other way. So basically, instead of first comparing tax ID, first name, last name, I'm doing from the other way. So first, I'm basically comparing the base of the class with that one. Then I'm comparing last names, then I'm comparing first names, and then I'm comparing tax ID. As you can see, it's really easy to do. It's like just adding one line, add line one. You don't have any things that you can really mess up here. It's really, really good. And if it can happen that the members or the base doesn't provide strong ordering, which is the strongest things here, you have a compile time error saying that you cannot pass the return type of all those operations to this type, because it doesn't. Some of the members doesn't support strong ordering, because, for example, it only supports equality operation. Here is what are returned things for specific built-in types. but I will not go through it because we lack of time a bit. If you would like to, can find it later on in the slides. And those types and such functions are put to the compare header. So you have some more helper functions that helps you to write your code with that. And there are also functions for comparison, compare freeway, lexicographical compare stuff, like for the strings and so on. And with that, header and feature relative operations that were in C++ standard for many years will be deprecated. Here we have some issue with comparing of object pointers. We right now decided to use the third option here. I will not go into the details right now, sorry, but we have like only 2 slots, and really I have like 90 slides. We are on 35. Okay, another feature is so-called synchronized buffer OSTREAMS. Basically what it means is that when you are doing streams in C++, it will create a buffer where you put all your data in, and then it will be atomically flashed to the nested stream, like to the cout. So basically you see here, you have here some stream that builds on cout, but it's like a buffer. You put stuff, and then you just say flash, yes? Once, automatically it will not have those interleaving of different operations on the console. Probably if you've seen, if you have multi-threaded operations, or at least, or sometimes you just pass things strangely from different classes. So basically, this is feature that will support that. It introduces 2 new types, new syncbuf with a function emit that automatically transfers stuff, and get wrapped. It's just getting you the stream you have in the buffer, and you said that it should emit on sync. So every time you do the sync, then here that it will emit stuff. And there is also an async stream that uses this buffer inside and pass those interface to the member. So this is the same interface. And this is basically how you use it. So here you have the async stream saying you have some out that's pointing to cout, and you type hello. There's no flash, you see nothing on console. You say emit. Basically characters are transferred to cout, but cout was not flashed, yes? You didn't put something like endline yet. So it's still not on, it's in cout, but not on the console yet, probably. Now you pass endl, yes, here. So it means you flashed cout. So flash is noted, but out is not flashed because it still didn't have emit. Only when you do emit, then everything is transferred to the cout, and this time it's flashed because there was endl here. And if you put it here once again, it was again not flashed to the cout. In this structure, it will be transferred to cout, but cout is not flashed because there was no endl here. So this is basically how this mechanism works here. You can also get the wrapped type from inside. So you have like cout here, you're passing here hello world, but in the meantime you are getting cout from it with get wrapped and create another async stream saying goodbye planet. And you can see that goodbye planet was printed first and hello world was printed second, because here is where the async stream out1 object was destroyed. So this is where it was, and its contents were passed to cout. So it basically helps us reuse the same resource like cout for many printing operations.
So the synchronization is on the per async stream object basis?
Yes. So yeah, synchronization or passing things to the like here, this flashing is being done, or the instance on the object. Yes.
If 2 threads take 2 separate instances, we will get the interleave, so we'll need to pass this async stream to both threads.
Yeah, basically, async stream itself is not thread safe, But I mean, if you will use in both threads, you will use cout, it will be atomically, the contents will be passed. So basically you may create async stream instance per thread, use them, using both cout, and just automatically transfer the data, so you should not have any interleaves on the console then. Yeah, there is another proposal called 753. It was said that if you are having streams but with OSTREAM base class, you don't know if this is a sync stream or not, so you cannot use this interface. You don't have this interface in the base class. So there were added a few standalone functions that just takes the basic async stream and they try to use those interfaces when it's the correct stream. So you can, when having async stream, you can assume that it's a synchronized buffer and use those functions. If this is not, it will just don't do anything. Yeah, we have like a few more minutes, so we'll go through atomic of shared pointer. This is new type added, so you will now have the shared pointer atomicity being done right. We did it in such a way. Some time ago, we had an atomic store function, and we were using it to basically pass things to the shared pointer, because shared pointer is not thread safe as itself. And it's true for the data it contains, but also about the class in some cases. I talked about it like for 90 minutes 2 years ago on Code Dive, so you're like, if you are interested in details, you are welcome to see it. This is fragile, error prone, it has many problems, so basically it was fixed. Basically we added the new specialization of atomic for shared pointer, now it works as expected. Also there is one for weak pointer. And it will now work really nice. And basically the atomic interfaces, those for shared pointer, will not be supported anymore. Talking about the atomics, we also support floating point numbers were added. Do you know what EBO means? It's empty base optimization. It's a technique used to make our classes smaller when our, let's say, template parameters are stateless. For example, our default allocator or default delete in standard are stateless, but you may know that probably all the containers store one or another inside, and you would not like to pay an additional bytes for it in your code. And in fact, you don't pay for it because empty base optimization allows you to eliminate that overhead if the class doesn't have a state at all. It basically starts with that every element of a structure has to have unique address. Yeah? So basically, if you would put like in a structure types that are empty, you will still have a structure that is not 0 bytes, and each member would have a unique address. But C++ standard allows that if you are inheriting from such an empty class, then the address doesn't have to be increased. And this is the technique EBO that is used for that. But it has limited applicability. For example, if you would have a default delete that's a final class, you will not be able to inherit from it. You have some name leakage. If your default delete has some interface, you or your compiler will see it. Even if you will inherit privately, it will still be visible by the compiler, but you will say like you cannot attend it because it's private, but it will still like mess with your namespace, providing all the interface of the base class to the external class. You don't want to expose the deleter interface in your class interface. And that's a bit awkward to implement inheritance just to eliminate size of the structure. So basically, we added a new attribute called no unique address that you can pass to things like hasher, predicate, allocator here for hash map. And then you don't have to inherit from them, you just pass them to the structure and basically stack pointer or the pointer to this class, to these members will not be increased when those are stateless. Of course, if they will have state, the stars will be bigger, let's say, than 0 or 1, then it will, of course, will increase it, yes? Yeah, it seems we have like run out of time. It's 9:45. We have 15 minutes to the next presentation. I can go with one more feature if you like, but it depends from the other presenter that presents after me. I think it's Odin, yes? Odin is not here yet, so if you like, I may continue or we can go to the break. It's up to you. Do you continue? With a few more minutes? Okay. Okay, so next feature is likely and unlikely. You probably knows those flags from GCC or other stuff. It was spelled differently and it was not portable between the compilers. Right now we added it to the standard. We can right now provide some hints to the compiler which branches are more likely to be taken than the other ones. Yeah, basically you are using this like this. So you say that you have a branch if for that it's likely, the compiler will be encouraged to optimize for running that function. Also here, if you would have it in the nested thing, it will also assume that if that is likely, then this one is also likely. So it will optimize for both those cases. In switch, you can also say that one of the cases is likely and optimized for that, like put it in the beginning of the binary tree or something. And you have also unlikely also, and you can use it in while loop like here, saying that it's unlikely that this foo will ever be true and this loop will ever go to the buzz. But please note, this is a dangerous tool. You can make sometimes more harm than good stuff here. Helping the compiler not always is the best things because compilers are pretty smart right now. The same goes with inlining and force inline tags and other tags you add to your code. Sometimes it makes more problems than good stuff in the program. So please note, this is an extreme feature. Use it with cautions and measure, always measure. Now, small stuff added by Howard Hinand again. Endian, finally, we'll know what is the endianness of our machine easily. You just type this. If our Endian native is equal Endian big, we have big Endian system. If our Endian native is equal little, we have little Endian. And there is also, seems to be a case for mixed Endian. I don't know exactly which platforms are those, but this is taken from the proposal, so I assume that Howard knows what are those mixed cases here. But basically, it's that simple. It's just an enum. It's just an idea to provide a good paper and provide help to many others. We fought with that for many years, how to address an endianness of our systems, and there are a lot of tricks to discover this in runtime, or compile time sometimes, but it's not easy and not trivial to find out. This was like a few lines of the paper to write, in fact. If you have ideas like this, please write a paper, or come to me and we'll write the paper together. And now a bit of C in C++, finally, we'll be able to designate initialization designate initialization of the structures. So we'll be able to provide initializers for X and Z, for example, here for the structure. And this time, Y will be initialized to 0, yes, because it's the default initialized value when you do the initialization of this type. Value initialization, yeah, exactly. This is the name. And you will have an error, compile time error, if you try to do it in the wrong order. Also, you can skip some of those if they can be initialized from the class, like the string will be default constructed here, B will be assigned with 42, not with 0, like here. And you just provide a new value for C that will override this -1. Also, you will be able to address unions with that. As you know, probably default construction of unions mean default constructing of the first member of it. Assigning to union or providing some here the initial value also covers only the first element of it. So if you are assigning one or constructing with one, you are assigning to constructing this A, yes? This one is illegal. You cannot initialize both elements of the union at the same time. This one is illegal too, because you cannot assign A or construct A that is integral type with ASDF. It will not figure out, like variant does, that you thought about B. But you can say, I want to initialize B with ASDF, and then it's fine with this new feature. And of course, providing both is wrong. And going with this initialization, there is also possibility to initialize bit fields in C++20. And with that, I think that's high time for having a short break before the next presentation. Thank you, and see you after the lunch.